Hi guys, we'll be starting this tutorial for Java and we'll be covering the OOPS concepts with examples. So later on we'll start with some basic concepts like what is a class, object and methods, and then we'll move on to the other advanced topics of OOPS. Now let's start with what is a class. So as you could clearly see, a class can be defined as a template or a blueprint that describes the behaviors or states that object of its type support. What it means is a class can be anything which describes a behavior. For example, there is a class called student. A Mohan is an object of this class is student. Now what all can a student contains? So normally, generally, what all student have? A student have the name, student have the address, a student have the standard in which he is studying, and student have some other attributes also that which belong to a normal student. So what I can have is I can describe all those behaviors, all those attributes inside a class called a student, and I'll name it as a student. And whenever I create an object of this class, then all those objects would be considered as a student. So all those objects which will be created out of this class will have the same behavior. They all will have a name. All of them will be having a standard. All of them will be having any other attribute that I have in my student class. So we'll first see how to create a class in Java. So when we create a class in Java, the first step is the keyword class, and then the name of the class. I'll show you in Eclipse how to create a class. So first let's understand the syntax. The next is the class body, which starts with curly braces, and between these all things related with that class means that property and method will come here. It can also the class can also be called as user defined data type. A data type is something which it's an object which inherits the properties of the parent class. For example, we normally in all the programming languages of the C++, we have something called int, and then so when we say int abc, that means all abc would be the integers. Like that, a class can be a user defined type. So here if you could see that student Mohan, so this Mohan is an object of type student. So it's a data type, but it's not a primitive data type, it's a user defined data type. I have defined the data type and I have named the data type as a student. So so the class can also be called as user defined data type. Now we will first see how to create a class. I have a package here. I'll say new class. I'll give the name to a class, that is a student. I'll keep all the other options as default. So here I have my class created. So the syntax is this will come automatically. So but if you program on a console, or if you're not using Eclipse, then you have to remember the syntax. It is the public is an access specifier. We'll come to that later. What are the access specifiers we have in Java? Then the class keyword is pretty important, and then the name of the class. So inside this class I can have attributes of my class. For example, a student can have a name, so I will define my variable here as string name, and I can say int or older int as you can say standard. So I can have few methods here which will give me the name, which will set the name of this student, like that. So basically this is how we create a class. So we'll come to we'll create this full-fledged class later when we cover the other topics. So right now just to create a class, we have this all you need to remember is we need to have provided access specifier. There is an option when you don't have to provide an access specifier, but that is a different case which we will cover later. Then the class keyword is pretty important, and then the name of the class has to be provided here. Then the curly braces and all those methods, variables will come inside this class body. Even you can write main here when you want to run this class, when you want to execute this class. So that's all about classes. Then we'll move on to an object. So what is an object? An object is an instance of class. Every object must belong to a class, and many objects can be created using one class. So many students can belong to a student class because they all inherit the same behavior. Each object has its own data but its underlying structure. That means every other student can have his own standard, can have their own name, but their structure, underlying structure, would always be same. So as you could see, the same example I'm taking here to simplify the things. That is a student Mohan, new student, and this I can have student Mohan, Ram, and a lot of other students here, which all will have the same behavior that the student class defines, which is defined in this class called student. So we'll move on to methods now. What is a method? A Java method is a collection of statements that are grouped together to perform an operation. So a method definition consists of a method header and a method body. So here are all the parts of a method. So what all method contains, they must have a modifier. The modifier is nothing but a public, protected, default, or private. So based on your decision, based on your design, you can choose any one of them. And then every method must have a return type. Every method must have a method name and the parameters and the method body. There are some instances where method does not contain a body, so that instance again will come later in this particular tutorial only. So how to write a method? We'll write one method here now. So this is how method looks like. I have my access specifier here. I have a return type here. So return type means I can have a return statement inside a method. So whenever my method needs to pass the control back to somebody who's calling this method, then it will return this particular kind of object or data. So this is my method name. I have a parameter. I'm passing just int parameter inside. So here I have a method body. So inside method body I'm doing some stupid thing. I have this condition called if id is equal to 5, return a student is a string, so my return type is matching, so there is no compilation error. If the id is not equal to 5, then return b student. Again, it does not make any sense though, but this is how our method works. But this is correct, it will compile, and this is how a method should look like. It should have a method body. Here inside this part you can write any code that you want as per your requirement, but the syntax would go like this only all the time. So these are all about methods. So we'll now come to the principle of loops. What are the principles? So one of the major principles is encapsulation, then we have abstraction, then we have inheritance and polymorphism. So one by one we'll cover each one of them, and we'll see how you can use these principles to write a program, to write an effective Java program. So before we get into those concepts, we'll first define what are the access specifiers we have in Java. So normally we have something called public, we have protected, we have no access modifier or defaults. So you don't have to write default. When you don't write anything, take it as default. Then we have private. So what that really means, so when you say public, when you provide public access specifier, that means this particular thing, whether it's a class or it's a method or it's a variable, it is available to all the classes, in your application. It is actually public. So and because it is public, it is available everywhere. That's why you have all these as Y's. Same package, yes. Subclass, yes. Other packages, yes. What is a subclass? Subclass is a class which inherits a particular class. So I can have a school class, and this student class can inherit that school class. So again, when I'm inheriting the school class, so all the methods or all the variables present inside that school class, if they are defined as public, then I can access them inside this class also. So that's what we mean by subclass. So when a class is public, it can be accessed inside a subclass as well, and in the other packages as well. When we have protected, there is something called protected access specifier also. So protected access specifier means it can be accessed in the same class, yes. Same package, yes. Subclass, yes. But other packages, no. These protected classes cannot be accessed outside the package. So what is a package? We have seen here, this is my package. So inside there I can have any number of classes inside this package. So the protected classes will be accessible only inside this particular package, not in other package. So when I say default means it can be again same class, yes. Same package, yes. Subclass, no. When it is default, so if my school class is default, then and student is a subclass of school, then student will not be inherit the properties of my school class. Other packages, again, no. So for private, again same class, yes, but nowhere else it can be accessed. So normally, as a design approach, what we have is we normally define our variables as private, because we do not want other classes to change the variables of my classes. I can have my method as public. I can other subclasses can provide their own implementation of this method based on their requirement, but the variables are pretty sensitive material for a class, so everybody will choose them to be private. But a method can be can be used somewhere else also. Its implementation can be changed based on the requirement at in other classes. So that's all about access specifiers. Now we'll move on to encapsulation. What is encapsulation? So encapsulation is nothing but a technique of making the fields in a class private and providing access to the fields via public methods. If a field is declared private, as we were talking earlier, if a field is declared private, the field is nothing but the variables inside your class. If they are declared private, it cannot be accessed by anyone outside the class, thereby hiding the fields within the class. For this reason, encapsulation is also referred to as data hiding. Encapsulation can be described as a protective barrier that prevents the code and data being randomly accessed by other code defined outside the class. Access to the data and code is tightly controlled by an interface. So that is nothing but, as we have discussed earlier, these access specifiers provide me a way to control that which data of my class can be accessed from outside and which data cannot be accessed from outside. So for example, if it's an bank account class, I don't want other classes to see the balance in my bank account class, so I can make that the method which is giving me my account balance, I can make that method as private. So no other classes can access this method, but The account's name means my name is, I don't want to hide my name, so I can have my name method as public, so it can be accessed from outside, but the account number will not be accessed from outside. So it is a way to hide the data. It is a way to design. It is simply a design approach, you know, that like what all data you want to hide, what all data you want to be accessed from outside the class. So that this is nothing but encapsulation. So then we will move on to abstraction. So abstraction is nothing but, you know, it's separating the functions and properties that logically can be separated to a separate entity, which the main type depends on. It is creating interface to denote common behavior without specifying any details about how that behavior works. So abstraction is nothing but generalizing the whole design. So how do you generalize a design? So in Java we have few things called interfaces. We have something called abstract classes as well. So first we will cover that abstract classes in an interface, then we will look into the example of abstraction. How can you implement abstraction in your Java programs? So in Java we have something called abstract keyword. So we have abstraction as a principle, we have abstract as a keyword as well. So the abstract keyword can be used in classes and methods, and the abstract methods does not have any body. Abstract method does not have any body. Abstract classes must contain at least one abstract method. The classes which contains the abstract keyword must contain at least one abstract method. And what is abstract method? Abstract method is a method which does not have any body. So abstract classes are incomplete classes because of the presence of abstract method. Abstract classes are incomplete classes because they contain a method which does not have any body, which is not defined. So that is why they are incomplete classes, and that is the reason why you cannot create an object. You cannot instantiate this particular class. That is an abstract class. So syntax of an abstract class is abstract. Just behind the class keyword you can have your abstract and the class name, and then the curly braces. Here you can write anything as per your requirement. So we have an abstract method as well. So it is abstract keyword void run. Void is return type. When you don't want a method to return anything, you can simply have void there, then you have run, and then your method body, and then semicolon. It should not have any body. So now we'll see the interfaces. So interface is a collection of abstract methods. So we have seen abstract classes. Abstract classes are nothing but they have methods which have body, and they have methods which does not have body also. So it's a collection of methods in which some methods can have body and some methods do not have the body as well. So it is kind of an incomplete class. So where do you use abstract classes? So we'll see where you can use abstract classes. So I'll take an example of shape class. So the shape is a pretty general term, and a shape has a name, and shape has a type also. A circle is a shape, a rectangle is a shape. So if I have my shape class, so here you could see the shape. A shape has a name called rectangle, and circle is also shape which has a name called circle. But the properties of rectangle and properties of circle would be different. A circle contains a circumference, where rectangle contains a side. So if I have a class called shape, and if I make a method inside this class which is get name of the shape, so that get name of the shape can return anything, rectangle or circle, anything. So that is a common method, because this method can be inherited in rectangle class as well as in circle class. So that I can have a body of this method called getName, because it is pretty common. But when it comes to get area of a rectangle, get area of a circle, and I cannot have the same method which is there in the shape class to be used by both of these classes. The getName method, if I write that getName method inside shape class, then it will work in the rectangle as well as in circle, because get name is nothing but getting a name of the shape. It does not depend on what kind of shape it is. It is just returning the name of the shape. But even if you say get area, you have to consider the way the shape is constructed. So the area cannot be generalized. The rectangle has a different formula to calculate the area. Circle has its own formula to calculate the area. The rectangle needs length and breadth to calculate the area, where circle needs only radius. So what I can do is I can have this abstract method called calculate area inside shape class, and when this rectangle class and circle class extend this shape class and become the subclasses of the shape class, they have to provide their own implementation for the get area method. So this is where abstraction is used mainly. So abstraction is like generalizing a thing. You have the one class called shape, and then you have other classes called rectangle and circle, which will inherit the general behavior of shape, but still there is some uncommon behavior which these classes can take care of. Just to extend this particular phenomenon, this generalizing the whole thing, this phenomenon of generalizing the things, we can have interfaces also. So interfaces are nothing but they are the super abstract classes. Super abstract classes means they have all the methods abstract. But here we do not use the abstract keyword. All the methods are abstract. All the methods are abstract. They do not have any body. So it is like a template of a template. It is kind of a class, kind of a template class, where you can define various methods, and it does not have any body also. We first look into the theory part, then we'll move on to the examples. So an interface is a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface. So whenever a class implements an interface, a class can extend a class, and class implements an interface. We'll see the difference when we go to Eclipse. An interface is not a class. Writing an interface is similar to writing a class, but there are two different concepts. A class describes the attributes and behaviors of an object. An interface contains behaviors that a class implements. You cannot instantiate an interface, means you cannot create an object of an interface. An interface does not contain any constructors. Constructors will come to that later. All of the methods in an interface are abstract. Okay, that point is getting repeated. An interface cannot contain instance fields. The only fields that can appear in an interface must be declared both static and final. What is final? Final is a keyword which we use to make sure that the state of that particular object or a variable cannot be changed all across your program, all across the application. So mainly for the constants, we use the final keyword. An interface is not extended by a class, it is implemented by a class. An interface can extend multiple interfaces. So now we'll see what is an interface and what is a class. So we'll first create one abstract class. I can mark this as an abstract here, but I'll not do that. I will have a shape here. So I will write abstract here. So here I have an abstract method called calculate area. So I have this abstract class shape. I cannot create an object of this class shape. So in order to create an object of this class shape, I should inherit this class. I should provide a mechanism where this calculate area method can have its body. So what I will do is I will create one more class. I will create a circle class. I will say extends shape. Now it will throw a compiler error because it is saying when you are extending this class shape, which is an abstract class, you must implement the inherited abstract method called calculate area. So it is a rule when you inherit an abstract class, you have to provide an implementation of the abstract method present in that abstract class. So if I provide the implementation of that abstract method, then my compiler will be fine. And the method signature has to remain same. And it can have anything actually. So here, based on your code, based on your requirement, you can return anything. You can calculate, you can write a code to calculate area, and you can return that particular area here. So but when I say return 1, it is just for an example. So it is returning an int, so that is why the method is complete. Now I have extended the shape class. So when you extend a class, you use this keyword called extends, and as we read for the interfaces part, when you use the interface, you have to use the keyword called implements. So this is how abstract classes look like, and this is how they actually work. So there's one thing that you need to consider is that abstract class must contain at least one abstract method. It can have collection of both the methods which have the body and the methods which do not have the body. So this implementation of this method depends on the kind of environment you're in. Like circle, you're in circle, so the calculate area would be different for circle. So you are in a single time you're generalizing a behavior, name of the shape. You don't have to provide the implementation of name of the shape here. You can directly use that method name of the shape here without writing a code for it. But this calculate area is pretty much dependent on a circle, so calculate area is a non-general behavior. So but you have to have your class to implement this method. Means you are forcing your class to implement this particular feature. Means you are forcing your class to provide an implementation of calculate area. When there is a need for such things, you use abstract classes. So interface also goes on the same lines. We'll create an interface now. We'll call it as vehicle. Interface has to be public, because if it is private, the method inside this interface has to be public, because when they are private, as we read earlier, then whatever is implementing this interface, whatever the class implementing this interface will not be able to provide the implementation, because these methods will not be seen in that class, because if they are made private. So this is the first thing that we need to consider. We'll have to have some public methods there. So I have an interface which contains two methods, and these two methods does not have the body. So this is mainly for again for generalizing, again for the abstraction, like you're generalizing a behavior. A vehicle is a class, but then there are different kinds of vehicles, and they have, you know, their own properties. They have their own number of tires. You have your bike also, you have your car also, but and both are considered as vehicles. So, you know, when you want to force certain things, certain, you know, attributes to your classes, then you make use of abstract classes and interfaces. Now, how do you implement an interface? Whenever you have a class, just say implements and write the name of the interface. So here you are implementing an interface. Now again, the compiler error I have is that this class must provide an implementation of the methods which were there in the interface, that is model and the number of tires. So when I provide the implementation for them, then this class would compile successfully. So I hope you understand that it is like generalizing the behavior. You want your classes, you want some behavior to be forced on your classes, that you have to have the implementation of the model and the number of tires in that particular class. Then you make use of interfaces. So that's all about it. That's all about the interfaces. And any class can implement any number of interfaces. I can have comma and I can have number of interfaces here, A, B, C, J, anything. I mean, I can have any number of interfaces in a class. For a class can implement any number of interfaces, given that it provides implementation of all the methods contained in all those interfaces. But a class can extend only a single class. A class cannot extend more than one class. So this is the difference that you need to remember. And there can be many number of interfaces that a class can implement, but there is only one class that a class can extend. And this class, you know, need not be an abstract class. This can be a non-abstract class also. So we'll move on to inheritance now, another OOPS feature. So inheritance can be defined as a process where one object acquires the properties of another. With the use of inheritance, the information is made manageable in a hierarchical order. When we talk about inheritance, the most commonly used keywords would be extends and implements that we have seen earlier. These words would determine whether one object is a type of another. By using these keywords, we can make one object acquire the properties of another object. So the circle and the rectangle is a shape. Circle is a shape and rectangle is a shape. So, you know, you're forcing a behavior, you are generalizing a behavior, and you're making your classes accordingly. So that is what inheritance is. So we have seen inheritance. Inheritance can be implemented by two ways, that is extending classes and implementing interfaces as well. So now we'll move on to another OOPS concept, that is polymorphism. So polymorphism is the ability of an object to take on many forms. So polymorphism is nothing but the same name but different nature. So in Java there are two types of polymorphisms. One is compile time, that is static, that is defined by method overloading, and there is another one called runtime, that is dynamic binding, that is called overriding. So what is overloading? We'll see. So if you have two methods with the same name in one Java class with different method signature, then it's called overloaded method in Java. In order to change signature, you either need to change number of arguments, type of argument, or order of argument in Java if they are of different types. Return type is not a part of method signature, so you can have any return type there. But if you want an overloaded method, then you have to make sure that parameters inside that can be changed, you know, or the order of them can be changed. Means one is int, other could be a string, so a string can come first and int can come second. So that would be a overloaded version of that method. So if you want to overload this method, you just have to first remove this thing. We have discussed that earlier. So if you want to overload this method, you can simply copy paste it first, and you know, I can have a single parameter now. So the name is same, as you can see, but the parameters are different. So this method is actually an overloaded version of this method, and this can happen inside a class only. And it is also called a compile time, because at the time of compilation, like at the time of writing a program, it gets compiled. So at the time of compilation only, this difference can be figured out whether it's an overloaded version or not. So compiler behind understands that this particular method, calculate area, is an overloaded version of this method at this line. So this method, calculate area at line number 9, is an overloaded merge version of method at line number 5. The compiler configures it at the compile time only. So this is what overloading is all about. Then we'll come to overriding. In overriding, a method in a parent class is overridden in a child class. The method in a child class will have the same signature as that of the parent class. Since the method in the child class has the same signature and name as the method of its parent class, it is termed as overriding. So we'll see what overriding is. So overloading is nothing but changing the method signature, and you can have your overloaded version of this method. But overriding is having, a same method, this method with the same signature, same name, but in the subclass, because you cannot have a copy of this method, same method, inside a particular class only. We'll see what happens when you do that. When you do that, here you see the compiler do not understand that which method, when the object is created, then which method it will call inside this class, either this method or this method, because both contain the same parameters, both have the same name. So the compiler get confused here. Compiler do not go inside the body. Compiler configures at the time of scanning the whole class, like which method it needs to call. So you cannot do this inside a class, but still it's a pretty useful concept to override a method. When you have so we'll use this student class only, our good old student class. I'll have this as student, and I'll extend this circle class. Oh, the spelling is wrong there. So now looks good. So this is a subclass. Now the student is a subclass of circle. Now based on this subclass, I can have its own implementation of calculate area. Means like circle again has a type, like circle has a semicircle. So if I have a class called semicircle and I say semicircle extends circle, and I have my calculate area method inside here with this, but then again the method inside a circle will again, calculate area method inside a circle should have only radius as a parameter, and inside a semicircle also you can have a radius as a parameter, or for an instance, if that also has a radius as a parameter, then but the formula would be different. So what you will do is you can override that method, and at the run, but the compiler doesn't know that when an object of a subclass is created, then which method it needs to call. Either either it can call the subclasses method or a superclasses method. So at the time of runtime, based on the parameters that you pass to that method, it configures that which method it needs to call. So that is why it is called a runtime polymorphism, and that is why it is called dynamic binding as well. So dynamic binding means at the runtime, your JVM configures like which method it needs to call, whether it needs to call the calculate area of semicircle or a circle, like or a subclass or a class or a parent class. So this is all about the basic groups concept that we have today. So in the next section we'll cover constructor, we'll cover this keyword, we'll have super keyword, final, and static in Java. So thanks a lot for your time. See you later.